Hello everybody and welcome back to the Moshix mainframe channel. This is Moshix. Just in the last 2-3 days, Fish, the main developer of Hercules, along with Ivan Warren, another very important developer, and of course several others, including Jürgen Winkelmann, one of the main contributors as well, and he is the maintainer of the MVS TK4 distribution. So they've all contributed to release version 4.2 of Hercules, called Hyperion. Also, everything above version 4 is called 4.0 and above is called Hyperion. That's the new project name. Of course, it's still Hercules, but 4 and above is called Hyperion, and 3 and above is just called Hercules. And of course, we still have Hercules 3.3 available, 3.13 available, but that's kind of stabilized now, and all the new development for the last few years, maybe 4 or 5 years now, has gone into Hyperion 4.0 and above. And in the last few days, Fish has made available 4.2 as a main release, released on the 8th of July. And so that's what we're going to look at today, what it is and how to make it work for your Hercules needs. So let's see what Fish released here. That's his page, Software Development Laboratories. That's why it's called SDL. If you also search on GitHub SDL Hyperion, you'll land on his GitHub page, and that's where nowadays most of the Hercules development is happening. As you know, or you may not know, but Hercules development split about a year or year and a half ago. Fish didn't want to, well, more or less be told how to write code, and so he split Hyperion into his own repository, which is called the SDL Hyperion repository, the one we're looking at the screen on right now. And that's where now all the main development is happening. So if you're using any other Hyperion source code, don't do that, and I advise you use this stuff. I know it's a little bit confusing, and that's a big pity. It's a shame that we as a community on Hercules have so many versions. It's so confusing to people how to land on the right Hercules source code, where to obtain it. If you want to follow my advice, you don't have to, but if you want to, I advise you just stick with this SDL Hercules 390 Hyperion. So if it doesn't have SDL in the name, then I advise you don't bother with it. Bug fixes, etc. are happening fastest in this branch. That was also, of course, the branch maintained by Jürgen Winkelmann for his MVS TK4, which includes a Hercules distribution as part of the overall package, but that's already quite a few years old, at least I want to say 3-4 years old. It's a very good version, a lot of bug fixes by Jürgen, but Jürgen is now also applying his bug fixes to this branch. So go with this. If you need a good Hercules version that works, is fast, has a lot of improvements both in execution speed as well as in functionality, go with this one. So having said all that, let's see what Fish released here the other day. So by the way, he also makes for Windows only precompiled binaries available, but the people in this channel, they like very often to roll their own binaries, and that's what we're going to do in this video, especially for Linux. But for Windows, if you want to go the fast route, just go here, softdevlabs/hyperion.html, as you can see here, and go get yourself these binaries for Windows. They work, they're good, and let's see what went into what the fixes are or the improvements are of this version. The release notes are here. So we've already discussed this in this channel in other videos. We have now huge DASD support, which is very, very important, because nowadays there's very little you can do with the 2 gigabyte with the 4 gigabyte limit we had in previous DASD sizes. You could define much larger DASDs, and when you created the DASD, you could create a 9 or a 54 gigabyte DASD. But at the end of the day, Hercules was only able to address 4 gigabytes because of 32-bit limitation. Now we have 64-bit support for DASD, so now we can go much larger. And again, in the mainframe world, 9 gigabyte DASD is still a big DASD. It's still a big disk. In the PC world out there, I think the smallest 3-inch drive you can buy nowadays in the US at any PC store is probably a 3 terabyte, and compare that with a with a 9 gigabyte, which is 300 times bigger, but smaller. But that's how it is in mainframe world. You don't need terabytes of disk unless you're running production. But none of us are running production on top of Hercules. It doesn't make any sense. So this is a huge thing, and I've been using it for at least 6 months or 9 months now, and it works nicely. Then let's see what else he has here. Machine check handler for Linux builds. Yeah, I've been running into this, so it's good if they fix that. They removed Regina from Hercules. You can still compile it in, but if you don't need it, then it's better to remove it. Less code, less bugs. They removed floating point, this instruction perform floating point operation, because it was never complete and it was causing bends for some workloads. So it's good to remove that. At some point it will still be good to have this instruction fully implemented, but half-baked implementation is helping nobody. Then this tape utility is very nice because it's compatible with the VM CMS tape utility, and that's a great way to put files into a tape image, which then VM 370 etc. can read. They disabled the vector facility because it was never complete. They only had 26 instructions implemented out of 180, and of course it makes no sense to have only a quarter of the instructions for any particular feature implemented. And there's not a lot of workloads on the mainframe that use the vector facility. There used to be maybe more in the 80s and 90s, but not anymore. Then they implemented the diagnose instruction X75, which is an instruction that allows old mainframe operating systems such as MVS 3.8 and VM 370 to have TCP/IP, which is very important if you want FTP stuff. There's some people implemented web servers for MVS 3.8 for a 35-year-old operating system, and that instruction makes it possible. It was designed or written by a fellow called Jason Winter. Great developer, by the way. He also, I think, worked for a while on putting in Unix called Xinu, just backwards of Unix, into MVS 3.8, but with a 24-bit address space. It's just not possible, and since we won't be getting any 31-bit operating systems, we're probably not going to get Unix into MVS at all, and some other stuff. So this is what went into 4.2. 4.1 release also had some great improvements, and of course overall also a lot of instructions have been made much faster. Let's see here what else we have. So internal instruction count accuracy, that's actually a bug that I reported, which then Fish improved. There were some issues when on the panel, on the Hercules panel, in counting the instructions being executed or having been executed. This one, I think I also ran into this bug. This one I've been also using a lot. So now we have OSA devices, which on the mainframe, on the real mainframe, the modern network devices are called OSA. Open, I don't remember anymore what this stands for, but and so this is seen as an OSA device by the mainframe operating systems such as Linux, etc. And it's called QATH at the Hercules level. I'll be making a video about this separately because this is important. I've been playing a lot with this new OSA emulation on Hercules, and it's truly a game changer for a lot of stuff. So a lot of fixes there. LCS has been broken for Linux for a while, for Linux guest operating systems on top of Hercules. So I'll have to see if it's been fixed now. And some other stuff. And of course this also contains all the fixes for a lot of other stuff. By the way, a lot of instructions have been made much faster, like this ones. So Fish and Ivan have a long-running project of improving the performance of a lot of the instructions, because there's a person who has been doing instruction measuring, instruction performance measuring, and based on that measure that was done last summer in 2018, now they've been improving one instruction after the other, making sometimes dramatically faster. So 4.2 is going to be quite a bit faster. And of course we have crypto was fixed in 4.1, which is important for Linux, and SSL, so you can do web servers with HTTPS or SSH, and so a lot of other fixes. So if you're running anything older than 4.2, you really owe it to yourself to go get this new release and make it work. As I said before, you can either get the precompiled version for Windows if you don't have a C compiler installed on your Windows, and otherwise on Linux I recommend you go get it and compile it. So let's do this for Linux. That's what this video is about. I have here a session on, I'm recording this of course on my Windows computer because recording software is much better from Windows, but we'll be working with Linux. I'm connected here to my Linux jump server, which is just a virtual machine running Linux, and which I always connect first to if I need to do some stuff on Linux. So let's see what kind of kernel I'm running here. So I'm running quite an old version. So what I could do in the meantime is apt update and run an update of this virtual machine, which I haven't updated in a while. Let's see how many packages need to be updated. 20 packages, actually not that bad, so I'm not going to bother with it right now. I could just now do upgrade and it will upgrade those 20 packages, but let's not bother with it. Let's instead go and compile Hyperion 4.2. What you would do here typically if you're starting from scratch is just say clone and then copy here the address of the repository on GitHub, and then just do a git clone and the address which we just copied. If you do that, it will install the whole source tree on your computer. Now in my case I already have that, I already have it installed, I already have Hyperion, so but I would like to update it. So how do I do that? As you can see here, this is Hyperion, the source code. Just to, for instance, this is the one that emulates the CPU. So they started development on this in 1994. Hercules is not a young project. And this is how the CPUs get emulated. That's all the C code. There is a bug, you're welcome to go in there and fix it. Of course, you need the principles of operation. So, IBM principles of operation. And the one thing about, so here's a copy of it, for instance. The one thing to understand about Hercules is that it emulates several architectures of the mainframe. That there's the S360, the S370, then there is the ESA architecture, the XA, the SA, and then now the 64-bit Z architecture. Those are actually quite a bit different, they have evolved over time, even though application software is backwards compatible. You know, Hercules needs to have a lot of code to emulate all those architectures. So you could run MVS on Hercules, and you could also run Linux 64-bit on Hercules. Now on a modern mainframe such as the IBM Z14, there's no way you could run MVS on it, not even MVS ESA, not even OS 390. You cannot run any 31-bit or 24-bit operating systems on modern mainframes such as the IBM Z14S. But Hercules has to emulate all those old and new platforms. So you can see the amount of work that goes into Hercules it's quite staggering. And of course, you know, at IBM the word Hercules is not to be spoken ever. But if you just forget about politics for a second, and just look at the engineering side of things, the work that goes into Hercules is really amazing. There's a huge number of, we can actually count the lines. Well, all the stuff is in subdirectories, so, but it's hundreds of thousands of lines of code to emulate all the stuff, all the peripherals, all the disks, all the channel subsystem, all the devices, there's so much that goes into it, and so this is the right time now in this video to thank all the developers such as Fish, such as Ivan, such as Jürgen, everybody else that I failed to mention right now, but also the testers and all the people who contribute in with bigger and minor contributions in documentation, in testing, in writing code, in fixing stuff, in reporting bugs. So thank you all. Anyway, so let's get working. So I already have here Hyperion installed. How do I update it to the latest version? I don't have to go and each time reinstall the whole source tree. That would be a waste. Instead, I can just do remove my make file. If I do remove makefile.in and remove configure, then I can just say git pull origin master. Okay, that's the incantation here. Okay, so if I write this, it will update. So you can see here it's obtaining, yeah, and so it created now, updated my source tree with the latest stuff. Now, how do we proceed from here? So now we have Hyperion, the latest Hyperion source code installed. What we also need to properly compile is we need to get the compression libraries, because those are not delivered as part of Hercules or Hyperion. You have to get the libraries so that the building of Hyperion will take those libraries as part of the compilation process. So I will put the links or the description on how to get those installed on Ubuntu or Debian. But if you search on the internet, Ivan Warren and zlib and bzlib, those are two popular compression libraries. This email chain will come up first, and what you find here is the name of those libraries. So you get these two libraries, and that will, again, I will make the two commands here available in the description below this video. What you would do is install zlib lg dev for development, and also this library. Okay, you can install both at once, and now of course it will say it's already installed. So we don't need it in my case, but I will make the commands here available in the description below this video. Let's go again to full screen mode, and now, so once we have those installed, we can now start building. How do we build? The sequence of commands now is really important, so I will also make the sequence of commands available in the description below this video. But the very basics of building Hyperion is this following sequence. You do first, maybe let's put a text file. We build Hyperion. It will be first you do autogen. Okay, then you do configure, then you do make, and if everything went well, you do make install. Okay, that's the 4 steps to build. You need, of course, before you can build Hercules, you need to have all the building tools available. So we will get to that in a second again, but you need to first know that you have everything you need installed on your Linux systems to build. So for that, you go to in the Hyperion directory, subdirectory, there's a utility or util subdirectory. So here's where you are, Hyperion, util, and if you do a list here, you'll see there's a build check, and this checks if you have everything you need to build Hyperion binaries. So if you run this script, it will check if you have everything. So this is everything you need: autoconf, automake, flex, gawk, gcc, grep, m4, make, perl, and sed. You need to have all those installed, otherwise you won't be able to build. One more thing that you need, which this actually doesn't check for, and I've actually reported this bug a few times already, you also need G++. Okay, if you don't have G++, it won't compile either, but it's not checked for. So make sure, other than this list here, you also need to do apt install G++. And of course, with me it's already installed and I have the latest version, so it's not going to install anything, but you need G++. And I will also mention all these packages in the description below this video. Okay. So once you checked that you have all these packages, now we can do the 4 steps procedure that I outlined before, which is build, which is autogen.sh, configure, make, install. Let's start with the first one, autogen.sh. This will now generate the configure script that we now need to execute. Configure checks this is a step in many packages, open source packages. You need to run the configure script. What it does is it checks all the compiler and linker compatibility with the project. It checks if all the features in the compiler are there to build what it needs to build. So it's a very important step. So we'll run this, and it runs for a few seconds depending on the speed of your computer. This machine here is a virtual machine, but it's running on an SSD, on an NVMe disk, on an i7 I think, so it's quite a fast machine. Probably your machine will be a little bit slower. As you can see here, there's a lot of checks that go into it, because it's checking that all the features that are written into the source code, that the compiler and the building environment is able to provide those features. So you can see here, it ran that. So now we can do make. Make will just means make it, build it. You could do -J if you want to spread out. If you have many cores or many CPUs in your system, if you use -J, you will use all those CPUs. But I just like to write make, and it's now starting to build. We can now go and see here. Oops, that didn't go very well. You can see here, I only gave this machine 2 CPUs and 4 gigabytes of RAM. That's more than enough for what we need to do. But you can see here, the building is actually taking quite a bit of CPU. It's already using 100% of one CPU. If you put the -J switch into make, then it will use both, all CPUs that you have. You can also say -J2, -J4 CPUs. You can limit. I just like to say make. I don't trust the parallel building that much. That's why I'm doing it this way. And then what is this thing here? Let's kill this endo. F9, and then we kill it with 9. Okay. So it's building here. Let's see. It's building all the source code. And this is the latest version, right? Hyperion 4.2. As you can see here, there's quite a bit of source code to build. So it will take a couple of minutes, depending on the speed of your computer and the speed of your storage. With me, it takes roughly, I want to say, about a minute. On this machine, I have much faster machines where it gets done in about 15 seconds. Let's see what else we can find out about. So one of the things is also, if you have any bugs, you can report your bugs by going to issues. And you will see that a lot of people report issues, and then they will very quickly respond to your bugs. So this is Ivan, for instance. He's just responded to a bug, and they will say it's a bug, or no, it's not a bug, or provide more data. Very often they will say, give me more data. I cannot understand your bug, or I cannot recreate your problem. For instance, this is interesting. So this is somebody said that as of 2015, all systems will only support operating systems running in 64-bit Z architecture mode. So that they're asking Hercules to comply basically with the principles of operation of the latest machines, which means that as of C14 you can only run 64-bit operating systems in LPAR mode. Non-LPAR mode does not exist on the real mainframes anymore. So of course they're working to provide that as well. Okay, so they're keeping up. Now these people, they don't get paid for any of the Hercules development, right? This is all out of the goodness of their heart, and that's why so much more we have to appreciate all the work to put into it and be nice to these people, and when we report a bug, not be aggressive or arrogant about it, but be thankful that they're even willing to entertain fixing bugs, right? Given the amount of code, is just amazing that I have some instances of Hercules running for a year and a half, 2 years, without ever crashing or going down. So the quality of the code is quite good, and it has improved over the last year and a half. There was a time 2-3 years ago when it was bad, but it's getting better. So here you see some of the bugs. Now, as I said before, there's many other, if you look for GitHub Hercules, you'll find other trees. So for instance, there is another repository here. I don't even know what this is. Oh, that's a game. There's another Hercules here, and this is maintained by Steve Orso. And so I don't know, it's very hard to follow the differences, so there are some issues here. And this, I think, builds 3.13 or 3.14, Hercules 3.14, but so it's the older version, but they do backport some bug fixes from Hyperion into the older 3.13. If you install, if you were to install Hercules through the package system of your Linux, let's say I'm in Ubuntu here, I can do apt install Hercules, then this will go and install 3.13, the latest version of the pre-built binary package. But that gives you quite an old version with some bug fixes ported over, but I really don't recommend you install it this way. If you want all the latest performance, all the latest bug fixes, you do it the way we're doing it right now over here. Okay, so this finished building it. Okay, so no errors. So make finished, and if you remember again at the 4 steps, so we did autogen, we did configure, we did make, now we do make install. I'm root here, so I don't need to say anything other than make install. But if you're not root, which is probably the better way to work, as you know, I don't like to work with sudo, but if you're a regular user, at this point you would need to become super user, so you would say super user do make install. Okay, and because you need to install it now, the binaries where the operating system can go find it, which is user local bin. So you do that, and this is the last step, and that's quite fast, especially if you have fast storage. It now installs all the binaries, all the libraries that it needs in all the right places. And we can go look where that right place is. Now, one thing to say at this time is self-built versions of Hercules do not mix well with the package installed versions of Hercules. So if you installed like this, then you're gonna get, as I said, Hercules 3.13 here, right? And that does not coexist well with the one that we just built. So you need to decide if you're going to be on 4.2 or if you're going to be on Hercules 3.13. If you're really an expert user of Linux, you can make them coexist by setting the appropriate environment variables, but it's easy to get confused, even for me sometimes. So I do have both usually installed just so I can test stuff, and believe me, 4.2 is much faster. But if you are not 100% feeling comfortable navigating Linux, then you should not have both installed at the same time. So let's see where it installed it. I know it's in user local bin, which is available through the normal path variable in Ubuntu. And so you'll see that we have here Hercules installed. This is the general binary. We have, of course, the 64-bit DASD units, the utilities. They've been all installed. And I have some other utilities here, such as download YouTube video utility and some other stuff, which has nothing to do with Hercules, but it's all in the same place. So let's give this Hercules a try. Let me see if we just start Hercules, we can go see what it says. I have a Linux version here, which will work just fine with the new Hercules. Ubuntu. Okay, so let's see here. This was built on July 10, 2019 at 4:56 in the morning. That's me. So we know this has been built today. We're using the latest version, Hercules 4.2.0.0. Okay, and it's SDL, Soft Dev Labs. And then it tells you what it is using. It's using shared libraries. It's using bzip support, which is the libraries I mentioned that you need to go install. And again, I will have, and the zlib support, I will have those commands listed in the description below this video. And so this is what we have. So let's see what's going on here. So I have a Linux installed with one disk. It's a 64-bit version of the disk, 10,000 cylinders, so that's a 9 GB disk, and I have 4 CPUs allocated to it. Why don't we go and make this work? I have to set up the network for that. That's fine. Okay. Just make the whole environment a little bit easier. Okay, so here's our Hercules mainframe with 4 CPUs, and let's start with IPLing this Linux machine. IPL from unit 120. Already Linux is coming up here saying it will boot Ubuntu in 10 seconds. So let's see when that starts, which should be just about now. Yes, and so it's starting. 71 MIPS. That's million instructions per second, 145. It's coming up. We should see here, if we press escape. Yeah, we should see here now Linux coming up. Yes, here it is. That's already Linux messaging. It's starting. See what else. If we type at some point, right now it's running at 100 MIPS, 140 MIPS or so, which is quite fast. For an emulation, of course, it's not going to be comparable to the running Linux on a real computer. Remember, we're still running emulated. Okay, so we can now run max rates to see what is the fastest we've run. It's 187 MIPS here. Okay, you see here we're running, the fastest we've done today is 187 million instructions per second. I have some computers which run up to 500 million instructions per second. So this is all working fine. Now let's go and try to log into this machine. Yes. And right now it's doing the SSL processing, the crypto that I was talking about before. Okay, and we're in. So how do we know this is really a mainframe Linux? Well, you can see here S390X, X stands for 64-bit. So we're running now 64-bit Linux on a mainframe. And we could right now oops, let's do it like that. writing a small C program, and if I do GCC, I hope I have GCC installed yet, test, oh, how did we call it? I don't remember. Yeah, test C. And if we say -S, we should now get some assembler. Yes, and we can see this is mainframe assembler, right? So this is the machine architecture, EC12. So this is, it thinks it's running on a Z12, which is good enough mainframe, plenty fast, and these are clearly mainframe instructions. Okay, that's mainframe assembler, but the notation is the new notation. It's not the normal IBM high-level assembler notation, but the notation doesn't matter, because what matters is the binary that comes out of it, and those are mainframe instructions. You can see here R11. Here it's setting, for instance, this is very typical. It's setting the return code register 15. It's setting that to 0. Okay, because we're exiting here. So this is very typical mainframe architecture, 100% mainframe. And oops. So we have a very good. We have GCC running. I could now. I probably need to set up the network route. Yeah, I would need to set the route add default gateway. We'll have to see. I probably have to get the network properly configured, but this can be. I've done it many times, and I've shown it in some other videos. This all works just fine. And okay, so we're running here Linux on the mainframe. We've built our, that's Hercules running. Again, max rates. Yep, that's us, and uptime should be a couple of minutes now. Yeah, 6 minutes. Okay, so we've seen how to build this. We've seen that it works just fine. We've seen some of the new features that go into Hercules 4.2. We've seen that it is indeed the SDL version of appear in the Daiduri command that you installed. You can either get the pre-built binaries for Windows if you don't have compilers on your Windows machine. Here, pre-built binaries. Of course, get the 64-bit, not the 32-bit. This one, right? Not this one below. And don't. I recommend you don't bother with older versions of Hercules. And there's so much new stuff that goes into it. If you want to have the most fun with Hercules, then 4.2 is the version to go. Thank you all for watching. Thank you to developers for making Hercules what it is. And if you have any questions about how to build it, how to operate it, please post comments below this video, or let me know which your favorite version of Hercules is. And for any other commentary, comments or remarks, please post below this video. Subscribe to the Moshix Mainframe channel if you haven't subscribed yet. Thank you for watching, and goodbye.